Hey guys, can you hear me? If you can, please thumbs up. Yeah, cool. Just a second, I'll share my screen. Can you see the presentation? Nope. Just a sec. Of course, we tested it earlier, but it doesn't work now. Okay, and do you see it now?
Yes.
Amazing. Great. So, nice to meet you guys. My name is Eric. And I'll be talking about scaling production data across microservices. I'll share with you some of the experience I got with Fiverr. So let's start. First of all, a few words about myself. Eric, 15 years of professional software development and management experience, 6 years practicing DDD, domain-driven design, and currently an R&D director at Fiverr, leading the buyers group. So just to give you some context, Fiverr is a global marketplace that connects freelancers and businesses for digital services. Basically, you can think of it like Amazon, okay? But instead of selling physical goods, we sell digital services. For example, logo design, voiceovers, even like programming and tech stuff, or basically anything that can be delivered in a digital form over the internet. So Fiverr was founded 11 years ago. We're now celebrating our 11th birthday. And as all good things, it started simple. Okay, we started with the classical LAMP architecture, but just instead of the P for PHP, we used Ruby. Okay, so why did we do it? It's the fastest architecture that you can have, so you can iterate. It's an all-time favorite. And we used view action caching, which is basically we cached the rendered HTMLs from the MVC, from the view layer, and we saved them in memcached. And it worked great. But then traffic grew, okay? And we needed to introduce additional components into our architecture to make it, okay? So first we introduced async writes to alleviate stress from Unicorn workers. So basically the way Rails works, it's very similar to PHP or Python. There's a thread or process per request. And we had lots and lots of traffic, and that created a bottleneck on our HTTP servers. Okay, so our way to work around it was just to make the writes, okay, asynchronous. So basically, what we did is that the Ruby on Rails monolith just forwarded any command, any write to RabbitMQ. Later, it was picked up by a worker and written to MySQL. And we still used memcached for for the view action caching. Okay. If you have any questions, feel free to interrupt me. And if it's too complicated, then I'll just answer to the end. And that's it. Okay. At some point, we had trouble maintaining the same cadence that we used to. Okay. What happened? So first, continuous delivery. As many web companies were moving fast, practicing continuous delivery, and had a few dozens of deploys a day. Now it's all the way up to 500 per week. As the code base and teams grew, deploys began to feel scary. Do you know how that feels? Any of you guys? If so, then write like a plus. I like that stuff. Nice. At least Kirill knows that it's how it feels. So basically, it began to feel scary. The logic of the business flows was very intertwined and would break occasionally when new code was introduced. Now, on top of it, the monolith, the Ruby on Rails monolith deploy queue was getting longer and longer, in part due to the fact that the test execution time was also getting longer and longer as more tests were added. Also, after each deploy, we took some time to monitor for errors and performance issues just to make sure we didn't break anything. Now, since everyone worked in the same code base, there was a weak sense of ownership, as everyone could approve every pull request regardless of the domain knowledge. Also, as the codebase grew, it was harder and harder to upgrade our third-party dependencies, Ruby gems in our case, so we couldn't use the latest and greatest tech. And as traffic grew, we couldn't scale a single area individually. We needed to add more copies of our entire Ruby on Rails monolith, and that required more and more resources to operate. So, next version of architecture, version 3. As always, for every problem, the answer is microservices. So we also took that path, and now our Ruby on Rails monolith was acting as an API gateway for all the post, put, and all the mutating requests. And it also contained our view layer. It was still implemented in ERBs, like embedded Ruby files or embedded PHP. It's like embedded PHP files or ASP Classic. It's pretty much the same. So every time we wanted to get some data or to perform a write, we would go to a microservice, use its HTTP API. If it was a get, it would just query the database to return the answer. If it was a write, like a write operation, we would use RabbitMQ to enqueue that command and fetch it using the worker and write it to the Mongo database. Okay. And it was cool. Now, our initial take, as many other companies, revolved around a microservice per entity. Okay, that's important. You can imagine it like pulling the M from MVC and putting it into its own service. For example, we had a user service, a gig service, order service, and even a requirements service. And it was amazing. We could use the latest tech outside the monolith because we were writing new services from scratch. Also, a service was owned by a single team, which created a better sense of ownership and expertise because it was separated from the monolith. What's more, there was no need to wait in the monolith deploy queue. Each microservice had their own queue, which was empty most of the time. And our cadence increased dramatically, and we were back to delivering great software faster for our users. So, any ideas what went wrong? Think of it. What went wrong? communications. Okay, any other guesses?
I would say everything.
As always.
Yes.
Okay, so I'll try to answer it. API Hell, good, you're getting closer. Okay. So the first thing that happened is as more logic moved to microservices, more and more features required complex deploy sequences involving the monolith and several other microservices. For every feature, suddenly you had to have like a coordination between the deployments. Also, our code evolved into a distributed monolith where business flows were orchestrated using network calls to microservices as opposed to just method calls inside the monolith. We didn't modularize our code, we just distributed it between network boundaries. Also, as service ownership was distributed among teams and features were using more microservices, there was more and more friction approving pull requests by service owners. Okay. Now, API Hell, Dimitri, let's talk about it. I also want to talk about another kind of difficulty we faced adopting microservices. Like many adopters, our services encapsulated their data and exposed it via an API. After a while, that API started to resemble a scaled down query language with endpoints like get all orders, get active orders, get delivered orders, and many, many more. And these diverse querying patterns put stress on our database servers, which required maintaining lots of indexes to cater for all these query patterns. Okay. Also, notice the order page shows data about the order requirements in addition to the order details. Yeah, ball of mud. It always happens. You see that red rectangle? This is the order page, but it also shows the order requirements. Okay. Now, order service and requirement service each encapsulate their data, so we couldn't use fast database joins to fetch it. Okay, instead, we needed to make several API calls to get all the required data and join it in memory. And all that using Ruby, which doesn't support async operations natively. Now, as somebody smart once said, there are only two hard things in computer science: cache invalidation and naming things. All those API calls were hurting our response time and increasing the code's complexity. So after a while, we, for the first time, sat down and proactively thought about our architecture and its goals. It's not reacting to growth, okay? It's sitting down, thinking about it strategically. What goals do we have for the upcoming architecture of Fiverr? So first, we wanted to break data dependencies between teams. Okay, like if I needed some piece of data from a service that's owned by another team, I don't want to create a pull request or ask them or nudge them about prioritizing it. No, I wanna be independent for consuming data. Also, the solution had to be optimized for query performance. Okay, Fiverr is one of the biggest websites in the world, in the top 200 traffic-wise. Okay, we get lots and lots of visitors every day. And we want the users to have an optimized and fast experience. So we couldn't settle on performance. Also, as Fiverr was growing and we had like, let's say from 50 engineers and higher, JSON wasn't enough. We needed some kind of type-safe data interchange between services. Also, we wanted to minimize or avoid caching as much as possible because it was hard caching all those API calls and then invalidating them. Now, I want to introduce another term. It's called the data dichotomy. Okay, data dichotomy is about a negative, something and its opposite. That's dichotomy. Data systems are about exposing data. Services are about hiding it and encapsulating it. Okay. So what were our choices? First, the first choice is to expose the data via the source database. Okay, we can query the database behind the service for the data. But it still doesn't solve the indexing problems because querying another service's database required additional indexes to cater for all query types. Also, it introduced a high level of coupling. A change in schema could break the system in a variety of ways. So, can we avoid coupling to the source database? Any ideas? But still get all those goals? Dimitri, you said API hell. How did you handle it? Okay, never mind. I'll show you what we did. Okay, so introducing ravens. We're a big Game of Thrones fans at Fiverr. And ravens are the way that how varies, I think, used to distribute information. So we did the same. We introduced ravens. Ravens are all about state change events. Okay, a raven exposes the smallest scope of an entity's model change. Generally, we have a raven for every single property of an entity. For example, gig title updated, or the status updated, and etc. A raven also contains metadata about its event time, entity ID, entity type, and etc. Ravens are agnostic to the command triggering the state change. Now, this is very important, okay? There are dozens of flows which can change an order's status, dozens of flows, but only a single order status updated event that gets published, okay, for all those flows. Now, this makes it easy for consumers. They need to only subscribe to a single event opposed to a dozen if we were to create an event per flow. This is very important. Many flows, one raven. Now, ravens are published upon state changes in every business flow. But initially, they are published by what we call init scripts, where we read the current state of the database, of the source database, and we publish those ravens. Now, as opposed to simple JSON, we used Google Protocol buffers, protobuf for short, for its type safety and code generation abilities. Okay, so now that we have billions of ravens, and that's literally billions, we need an efficient way to transport them to their consumers. We decided to introduce Apache Kafka instead of relying on RabbitMQ. Why did we do that? First, because it's persistent. It buffers messages for consumers, which can read those messages at their own pace. Also, at Fiverr scale, it's important that Kafka is partitioned for scalability. And it also has an ordering guarantee per topic partition. This allows us to alleviate race conditions. I will get into the details about how we leverage this shortly. Also, Kafka offers log compaction. It retains the last known value for each message key and drops all the messages as newer ones are added. For example, I have an order status updated. Kafka will always keep around the last order status updated message for a particular order. But over time, it will drop order status updated messages. Okay. Kafka is also used by popular stream processors and data aggregation tools. And lastly, Kafka as a service is available. Operating backing services is not Fiverr's core business, and we like to use managed services when they're available. So what's the destination for all these ravens? It's read optimized views. But first, what are projections? Okay, a projection is a piece of logic which consumes a raven and updates a data view. Simple. There are generally two types of projections. One is stateless, for example, replacing a user's email address with the current value from a raven. Another type is stateful, for example, updating the number of orders in queue, which requires remembering all the pending orders for a given seller. Most importantly, a projection must be idempotent. Okay. Do you guys know what idempotency is? Idempotency? Plus. Anybody with a minus? Hey, all positive. Okay, I'll be very brief. Basically, idempotent writes means that you can run the same command as many times as you want. You will not change the result. Okay, that's idempotency. And that's very important for ravens because we wanted to make sure that processing the same raven multiple times shouldn't change the outcome. And this can get tricky for stateful operations, as we need to avoid simply incrementing or decrementing a counter, which might get out of sync for stateful projections. So what's so special about read optimized views opposed to source data? Well, first, the data is owned by a single team, which is great for ownership. Okay, the consuming team is the owner of the read optimized view. Now, read optimized views offer pluggable storage. You can use the best tool for the job. If you need, you can use Elasticsearch. If you need searching, MongoDB, if you need a document database, or just use MySQL or any relational database if the use case calls for it. Also, read optimized view should serve only a single microservice. Okay, we wouldn't want to tie multiple use cases or multiple experiences to the same read optimized views because it will not be that optimized, right? Also, it should be optimized for the data querying use case. You need a reverse index, a key value storage, no problem. Just use it for that read optimized views. Also, read optimized views are disposable. They are not the source of truth. You can always delete the read optimized view and replay it from Kafka. Just set the topic offset to 0 and reprocess. But most importantly, no caching and no cache invalidation is required because the reads are already optimized. So, following up on my example about the order page, we introduced a new microservice, or more specifically, a micro front end, and it's called, unsurprisingly, order page. This service would subscribe to all user and order state change events and would project them into its own private data view. We chose to use MongoDB for this one. We stored all the documents indexed by the user ID together with the order ID for fast retrieval, because that's the structure of the URL for an order page. It's user ID plus order ID. And to get maximum performance, we stored the order documents pre-joined with the requirements data. So no need to make separate API calls. By the way, in addition to projecting its own data, the order page service also served the order page horizontal React application. So it was data plus a front-end application that queries that data and renders the required HTML and CSS. Now, some benefits. Ravens have been a true enabler for us to scale micro front-end development. They helped us to dramatically reduce response times. And again, all this with no caching. Finally, I want to tie everything together and discuss orchestration vs choreography. Anybody knows what that means? Plus.
Of course.
Not in dancing, in software.
The Docker orchestration.
It's not about Docker, but I'll tell you what I mean in this context. Okay, so it happens that a lot of business flows need to trigger another action in a downstream service or module. For example, when a buyer completes an order, we need to transfer funds to the seller. Okay. Now, monolithic code tends to lean heavily towards orchestration. It's just very natural in a monolith. Okay. In our previous example, the same service object calls the complete order method, and just right below it follows the transfer funds to seller method. That's orchestration. We have one component that does the command and following all the side effects. Okay, it's calling complete order, one line below, transfer funds to the seller. And as we moved more business flows to microservices, we wanted to shift to choreography, where we would publish an auto-completed event and subscribe to it in order to transfer the funds to the seller. Why? Because the flow for transferring funds to seller is probably owned by the team that's responsible for the sellers. Okay, not for completing an order by the buyers. So two services might be owned by different teams and communicate using events in the pattern that's called choreography. Now, this will reduce the coupling of business flows and eliminate cross-team pull requests to upstream services, because if you use choreography, you don't need to create a pull request to update, to transfer funds to the seller, because you can write it in your own code base. Now, should we use Ravens to enable this choreography? Well, originally we wanted to use Ravens to trigger the downstream business flows, but we quickly realized that it just didn't make sense. A producer could republish the order status updated event with a complete status, but we wouldn't want to transfer additional funds to the seller. Okay, we can run these init scripts multiple times, and we don't want the seller to transfer additional funds to the seller every time. So, but making this business flow idempotent is redundant complexity. We don't have to do it. Also, lots of times downstream services need the context of the upstream business flow to adapt its behavior. For example, sending a different email if the order was completed by the user or completed automatically by the system after 3 days. Okay, so both of these flows would publish the same Raven, or the status updated. But this Raven was published because of different flows. One could be a user completing an order, and the other could be the system automatically completing the order. Basically, Ravens are optimized to transport data, and we shouldn't abuse them with all kinds of context from business flows. So, what's the solution? We introduced another kind of event, domain event. We use domain events to capture state about the result of a business flow along with its context. Continuing our example, we would publish order completed by user and order automatically completed, allowing downstream services to adapt their behavior, and they could send different emails, for example. And yes, the event names could get pretty verbose, but at least it's for the better. It makes it much more clear. So now it's time to put everything together. Let's zoom into the complete order by user business flow. It would publish a Raven, order status updated, which contains the updated order status. And finally, would publish the order completed by user domain event. Okay, so we publish both the Raven and the domain event immediately afterwards. And the order is important and also guaranteed by publishing these events into the same Kafka topic partition. Remember, I told you why it's important that Kafka maintains the ordering. Consumers expect to get the data before taking action upon it. For example, projecting the new order status from the Raven before fetching it in order to send the email, the user the email about the change in the order status. So if we publish the Raven first and the domain event later, the consumers get to read the Raven first, update the order status in their database, and only then they get that domain event, fetch the order from the database, and send the email with the updated status. Okay, so now it's time for some key takeaways. First, practice evolutionary architecture. Start simple and work your way to more complex and flexible architectures. Fiverr has been around for 11 years, and we didn't start with microservices or Kafka or events or domain events. We started with a simple Ruby on Rails monolith. And I suggest you guys start simple too. Second takeaway, don't ignore the data dichotomy. Treat it with respect and be conscious of the trade-offs in query patterns. If you end up hiding and encapsulating the database using a service, just be aware of it, that you're paying a price and you will need to provide APIs for every query pattern, opposed to just querying the database, which offers a far richer query language. If you do encounter similar problems to Fiverr, use state change events and read optimized views to decouple querying patterns and increase performance. And remember that they are not mutually exclusive and their ordering is important. You need both Ravens and domain events. And that's it. Thank you, guys. Do you have any questions?
Hello. I have one. I don't understand really how if you have a state change request to your API, and this request stuck in the queue, and how the client will receive the response from your API, or you use something like real-time API?
Mm. So if I understand your question, you're asking about the publishing service, like how does the consumer know that the event was processed or it was processed successfully?
I ask if we have API like REST,
Okay.
yeah, like REST, and your API receive state change request, post request, and after that, this request go to the queue, and we have a high load system, and this is may take a time, and how client will wait the answer from your API what the operation is successful.
Okay.
It's your flow, for my opinion, it's possible only if you use something like WebSocket real-time API, because
Well,
it's based on event based architecture.
Yeah, I'll clarify. Basically, the state change events are not published in REST. They are published to a queue. Okay, Kafka is a message broker, very similar to RabbitMQ. And this way, the consumers read the state changed events asynchronously. We don't wait for the browser, like the browser doesn't wait for all the consumers to finish processing the events. All the HTTP request does is just write it to a queue, and that's it.
Okay, I understand. It's through you work through WebSocket. Okay, it's understandable. But not all kind of API could work in such an architecture like you show. Yeah.
Yeah. We need some kind of we need a way to tell the result of the operation back to the user. That's correct. Sometimes right now we use WebSockets for returning the result of the operation back to the browser. But before that, we used polling. But yes, you're correct.
Okay, thank you.
Great.
And also you have introduced many new terms like ravens and orchestrator or dancing orchestrator. It's something real new because I never heard about it.
Well, basically, ravens is our own term. It's not that popular, but domain events is actually a pattern. It was coined by Martin Fowler.
Oh, okay. Thank you.
Great. Thank you, Yuri. Any other questions? Okay, great. Thank you guys for your time. Hope you learned something new, or at least wrote down a bunch of terms you can Google later. And we're always hiring at Fiverr, so if some of the stuff sounds interesting, jump to our website, to our job page, and good luck. I'll share my presentation with Kirill, and I'm sure there will also be a video recording of this session if you want to review it later.
Okay, thank you.
Great. Have a great evening. Thank you, guys.